is Jim Lewis from the University of Nebraska-Lincoln. Over the past 10 to 15 years, he's been developing one of the most successful and productive teacher preparation programs in the U.S., and he's going to tell us some lessons learned.
Okay. Well, thank you very much. I want to thank you for the invitation to visit. My first time in College Station, and happy to be here. And I'd like to talk to you about teaching teachers mathematics, because I come from the University of Nebraska-Lincoln. I want to always credit the National Science Foundation for all the money they've given me. Greatly appreciated. But before I get started, I'd just like to ask you to look at this. I was sitting in the airport, or maybe I woke up in the morning and got the USA Today at my hotel in Washington, D.C., and this was the upper left-hand corner. And so somebody tell me what jumps out at them about that message.
What point from being merged?
I think one airplane costs more than that, doesn't it?
The 3 airplanes there surely cost more than $1.4 million. All right. Now, USA Today, which would be horrified if they misspelled travel or something like that on their front page of their magazine, their newspaper, could put $1.4 million there because I think the eyes glaze over as people read things about mathematics, and they don't think that there's not a snowball's chance in hell that it was a merger between Southwest Airlines and AirTran for $1.4 million instead of $1.4 billion, which is a factor of 1,000, of course. And so this is typical of our society. So I'll talk about what I think is the case for why math teacher education should be a priority for universities, what mathematics should teachers know and how should they come to know that math, and a little bit about what we did in Nebraska. Okay, so math creeps into public life as comedy, and so that sometimes we focus on the whole numbers and count the 4 versus 2 in the assessment of the sentences, all right? And it's humor. Or, like here, we just refuse to do the math. And especially when things have to do with fractions, an awful lot of people just refuse to do the math. But a few years back, about 7 or so now, maybe slightly longer than that, a publication called Rising Above the Gathering Storm came out, and it said that U.S. competitiveness depends on dramatic improvements in math and science education of K-12 students. Now, it's interesting that this committee was created at the request of Congress. And Congress asked for, tell us 10 things we can do to ensure national competitiveness. All right, we got into this economic competitiveness phase, and they came back and said, we'll give you 4. And the first was dramatic improvement, increase America's talent pool by vastly improving K-12 science and math education. A few years later, President Bush's National Math Panel report asserted to compete in the 21st century global economy, knowledge of and proficiency in mathematics is critical. And then 5 years later, they came out with Rising Above the Gathering Storm Revisited. And it said there's little signs of improvement, particularly in math and science. The unanimous view of the committee members is that our nation's outlook has worsened, and the 2 highest priorities for the nation are to provide teachers in every classroom qualified to teach the subject they teach and to double the federal investment in research. Okay, so importance, if we're not getting the job done, things get worse, and math and science teachers are one of the most important things we can focus on. So I looked up a little data, and here's one view of how the nation is doing on the National Assessment of Education Progress. It says Massachusetts is the top state, and well, I think of Colorado as somewhere in between Texas and Nebraska, sort of, and the nation on an average, and the bottom, District of Columbia, you look beneath the surface, here's something interesting. Now, here's a really interesting math problem. All right? How can Texas be 16th among all students, and 5th among white, 4th among black, and 4th among Hispanic? So, it has to do with the percentage of people you have in each, or the number of people you have in each population group. Right? In some sense, Texas is actually doing a lot of things right. Right? Relative to the rest of the nation, maybe not relative to Asian countries or PISA or a bunch of other things, but Texas looks really good. Nebraska looks really bad. Nebraska is particularly bad at giving a successful life to ethnic minority students in our public school system.
Yeah.
And
Why compare with Kansas?
I forgot to change that.
Oh.
I got up this morning and changed it from a talk about Texas, from Kansas to Texas. Kansas is doing pretty good too, just as Texas is. Sorry, thanks. All right, so what do I think? I think society expects universities to make major contributions to improve K-12 education. And in particular, they expect us to improve math education, play a role. I believe that investing in high-quality teachers is the single most important thing we can do to improve K-12 math education. I mean, a lot of other things. You like technology. To me, the number one thing is invest in teachers. And I actually think math departments will thrive because of it, if they take the lead. On my own campus, we have received a lot of resources in the math department because we're perceived for making a big contribution here. All right. Now, here's something on the realities of scale. Teachers are the largest occupation in America. All right? There are more teachers than secretaries. There are more teachers than janitors, maids, and household cleaners. Way more teachers than architects, psychologists, physicians, and surgeons. And so, practically everything we might try to do, the reality we have, is driven by this issue of scale. Why are teachers not paid them enough? Because there's so many that society won't find the money to do it. All right? And if you want to change education dramatically, you can't change it just by educating the next generation, who are the undergraduates in our colleges and universities. There is this enormous workforce who need, in, say, today's date, or outside of Texas, of course, to be up to date with the Common Core. All right. So the issue of scale is something really important. So here's a very cynical view of education. K-12 students don't learn challenging math. Those that go to college unprepared for college math, the ones who do understand math often don't go into teaching. All right, so the students who haven't learned math go to college, and then future elementary school teachers don't take very many math courses. Those taken by secondary teachers don't prepare them to develop math knowledge for teaching. They go out into schools and are apprenticed by people who don't know enough mathematics, and then they become a teacher and they're left to their own device for continuing mathematics education. All right? And it's sort of a vicious cycle. You'll remember Li-Ping Ma's thesis said that it would take a very long time to change education in America. And so what's the result? Teachers don't know the math that they now will need to teach. Many teachers don't have an opportunity to learn math in pre-service preparation programs or professional development in any methodical, sustained, planful way. Now, all of these comments were made by Suzanne Wilson, who is chair of teacher education at Michigan State. She's now in Connecticut, on the faculty, I think, at the University of Connecticut. And she gave a presentation in 2011 at a conference that I organized. Okay, so here is the truth, at least in Nebraska. Historically, Faculty and College of Education thought teacher education was their job. They taught a lot of pedagogy courses, a lot of ed psych courses. They certified teachers. They said they thought content knowledge was important, but their requirements told a different story. All right? Mathematicians taught math courses, sort of according to the Marie Antoinette School of Education, let them eat cake. You know, we have math courses, come take my math courses. They had a little respect for students who wanted to be teachers, especially students who wanted to be elementary teachers. and there was very little communication between the two departments. And this is the historical thing that existed. Okay, so if we want to change things, we ask, what math do teachers need to know, and how should they come to know mathematics? And what does it mean to offer challenging courses and curricula for math teachers? How do we help teachers translate the math they come to know into classroom practice that leads to improved student education? That's the real goal. Okay, can you multiply 49 times 29? Fine, of course you can. What fourth grader wrote this? Deborah Ball used this roughly 4 years ago in giving testimony before a U.S. House Committee. Right, what's a plausible explanation?
I don't think I've seen this one before. Okay, so she's multiplying 5 by 49. Yes. So there's something about the carrying that's being screwed up.
Anyone else have an insight here that'll build on what Roger said? Five times 9 is 45. Carry your 4. You have 4 plus 4. That's 8 times 5 is 40. 2 times 9 is 18. Carry your 1. 2 times 4 plus 1 is 2 times 5 is 10. Order of the operations that the child might perform the operations.
Yeah, if you've taught third grade, you see that all the time.
Okay, so anyway, this was part of Deborah's testimony to Congress. So what's difficult about the math preparation of teachers? So Hung Si Woo, a friend of ours, said our universities do not adequately prepare math teachers for mathematical needs in the school classroom. Most teachers cannot bridge the gap between what we teach in the undergraduate curriculum and what they teach in school. We have not done enough to help teachers understand the essential characteristics of mathematics, precision, ubiquity of logical reasoning, coherence as a discipline. And then he said the goal is not to help future teachers learn mathematics, but to make them better teachers. So I mean, if you change your mindset, the goal is to be a better teacher. You learn math for the purpose of being a better teacher, not because you just love mathematics and want to learn more mathematics. Okay, and what did Roger Howell tell me about 10 or 12 years ago? He said the math taught should be connected as directly as possible to the classroom. This is more important the more abstract and powerful the principles. Teachers cannot be expected to make the links on their own. Get teachers to believe that math is something you think about, that validity comes from inner conviction that things make sense, that mathematical situations can be reasoned about on the basis of a few basic principles. The goal is to have teachers develop flexibility in their thinking to be able to reason about elementary mathematics. All right. So I've been using this kind of advice for a very long time with the issue of what math should teachers know and how should they come to learn that mathematics. And so fairly recently I was working with a group that produced a book called The Mathematical Education of Teachers, and we call it TAMU because back in 2001, Roger and I and a group of others produced a book called The Mathematical Education of Teachers. Core ideas in the book. There's intellectual substance to school math. Proficiency with school math is necessary but not sufficient for a teacher. The math knowledge needed for teaching is different from other professions, and the mathematical knowledge for teaching can and should grow throughout a teacher's career. Okay, so 4 basic ideas, and here are the various people that some of us are friends with a bunch of these people. And so 6 recommendations. Now, some of you never heard of this document? Okay, so I don't want to repeat what people already know. I'm sure they need to understand.
Doesn't hurt to hear it again.
All right. First recommendation: teachers need math courses to develop a solid understanding of the math they will teach. Now that, back in 2001, is what I used to call a silent revolution. Not let them eat cake and take calculus and difference of equations, but math that they will teach. The math knowledge needed by teachers is substantial but different from other professions. Teachers need to understand fundamental principles that underlie school mathematics. Coursework for teachers should examine the math they will teach in depth from a teacher's perspective. And the second one, opportunity to learn. Elementary teachers, and by that we mean K-4 teachers. K-4 teachers should take at least 12 hours focused on fundamental ideas of elementary mathematics. Now, I know your basic requirements require undergraduates apparently to take calculus. Not exactly sure that's all that relevant to be a second grade math teacher. All right. Middle grade teachers, starting in grade 5, we recommend 24 hours of mathematics. It includes 15 hours of fundamental ideas of school mathematics, and then maybe things like the calculus scores. And high school, the equivalence of a major. Like there's something specially said, including 3 courses with a primary focus on math, high school math from an advanced standpoint. And so at every level, we're recommending courses that are especially designed for teachers. And for those that are in the business of secondary math education, the typical probability statistics course that teachers take that is taught to the engineers is practically useless for the mathematics and statistics that they'll be asked to teach in high school. All right, teachers need opportunities for professional growth. And we presented an idea that in school districts, the principal wants to say, all my teachers are great, equivalent, good, because the principal doesn't want someone saying, I want my child moved to Mrs. Jones's class, right? Because this other teacher has a reputation. So we want to pretend that the beginner is as good as the veteran teacher. And it's just not possible, all right? So we state that the reasonable goal for initial teacher certification at the secondary level is beginning teachers able to teach a portion of their curriculum. That are what we call well-started beginners. All right, they're ready to start, but then they need future opportunities for professional growth. And all courses should develop the habits of mind of a mathematical thinker, problem solver, reasoning, explaining, modeling, scene structure, generalizing. Courses should be flexible, interactive styles of teaching. To help teachers achieve the common core, teachers need not only to understand the practices of the discipline, but how those practices can occur in school mathematics and be acquired by students. Teacher education must be recognized as an important part of Math Stat Department's mission, should be undertaken in collaboration with mathematics educators. So all through this, you will see mathematicians should be involved, but it should be done as a partnership. All right. More faculty should become involved with their school districts. Math Stat departments must provide graduate level courses designed to meet the needs of professional needs of pre-K math teachers, pre-K-12 math teachers. And the math education will be greatly strengthened by the growth of a math education community that includes mathematicians. We need more mathematicians involved. And so why should you involve mathematics? Well, to touch the future, which was a publication that came out after the Challenger explosion, said the essential competencies of an effective teacher are command of subject, preparation and effective pedagogical practice, and high overall achievement. But mathematicians cannot do it alone because this is an interdisciplinary profession. You have to know the discipline you teach, you have to know how to teach, and you have to understand the people you teach. And so all of these things are important, and so that's why it should be a partnership. The National Math Panel again said math teaching is extraordinarily complex activity involving interactions among teachers, students, and the math that they learn need to be learned in real classroom. The value added by collaboration cannot be overestimated. All right, so why do we get along? So this is one of my favorite quotes. When people belong to two different cultures, a lot of people's solution, if the other person would just understand I'm right, all right, if the other person would just be like me. And so there's a song from My Fair Lady where Henry Higgins says, why can't a woman be more like a man? And here's another. Ron Graham, someone, of course, friend of Rogers, I'm sure, and in an article in the Atlantic Monthly in 1987, there was an article about Paul Erdős, who was a very famous mathematician, and Ron Graham was basically Erdős's keeper. He took care of his finances and things for him. And apparently the sign said, anyone who cannot cope with mathematics is not fully human. At best, he is a tolerable subhuman who has learned to wear shoes, bathe, and not make messes in the house. Now, that article in the Atlantic Monthly resulted in the U.S. Senator from Nebraska, Bob Kerrey, who later ran for president, tearing the thing out, sending to me, and when I was chair of the math department, and saying, Jim, if this is the way mathematicians think, no wonder none of us like you guys. So,
The interesting thing is it doesn't describe Ernest very well, does it?
and so I went to my wall, took off the wall William Faulkner's Nobel Prize winning acceptance speech. And it was tattered by this because it had been on my wall for over 25 or 30 years. And I photographed it, scanned it, and sent it to him, and I said, this is what's on my wall. And he read it, he promised that he would keep it on his wall for 20 years. But it's a very different statement. All right, so let me tell you a little bit about what's in the MET2. When we talk about elementary teachers, it's organized along the Common Core, and one part of it is operations and algebraic thinking. And so we take commutativity of multiplication. It's not obvious, all right? And the way a lot of times we teach kids about multiplication, we talk about 3 groups of 5 or 5 groups of 3. And there's actually no reason in the world that a child should understand there's the same number of dots there. And that these should be recognized. And yet if you shift to a fairly simple rectangular array, and you think of it, there's one way you can think of it, and here's another way you can think of it, and the dots never move, and so it's the same. So we've got to think about how we present mathematics and understand ideas like commutative property need to be highly visible rather than in some sense totally ignored, which is quite often what happens. Middle grades, people will talk about ratio and proportion. So here is a so-called ratio table. If 100 miles matches 4 gallons, then 200 is going to match 8 and 312. And you see the growth, and a different version, people often talk of a double number line, and you just match up the things that correspond to each proportionally, and you figure out the right place. So let's say that we needed to learn something about 325 or 375. Well, if you figured out that 25 goes with 1, you might subtract on the ratio table, or you might just like split from 300 to 400 to find that 350 matches with 314, and split between that and 400 to find out what matches with 375 would be 15. And so we recommend this kind of approach to understanding ratio and proportion before you set up ratios and cross-multiply, perhaps without really knowing what you're doing. In high school, we talk about what Felix Klein, one of the most famous mathematicians that ever lived, called a double discontinuity. Roughly, the high school, in his case, male, young student, was confronted by, goes to college, he's confronted by problems that didn't look anything like what he did in high school. Then he becomes a secondary math teacher, and nothing he sees in the work he's supposed to do to teach math looks anything like what he studied in college. And I certainly had high school teachers tell me that absolutely nothing in the major, they had their fun with their major, but nothing in the major really helped them to be a teacher. And so we need to pay attention to those things. And so that the math that people are studying needs to be tailored to the work of teaching, examining connections between middle grades and high school and college. And we come back to this theme, it's impossible to learn all the math one can use in any profession, including teaching, in 4 years, so teachers need continuing opportunities to learn. And we made some recommendations about what the major should be for secondary teachers. And we made recommendations, one of which we call the short sequence. And a way to describe this is roughly 8 courses past calculus. All right? And for many a university, that's the most they're willing to ask of a secondary math teacher. And so we recommend what courses it should be. And we also recommend a long sequence, which is roughly 12 courses, or 11 or 12 courses past calculus, and we make recommendations of that. All right? what should be the goal, mathematical knowledge, for teaching? We're preparing someone for a profession, just as if you're teaching math, prepare someone to be an engineer. And not just general learning of mathematics. Deep understanding of the content, things like representations and connections, understanding student thinking, assessing student learning, making curricular decisions, but paper by Deborah Ball and others, this type of knowledge is not typically gained through most pre-service math programs. So, I want to tell you a little bit about what we have done in Nebraska. It began in 2000 with a $200,000 grant that we call Math Matters. Ruth Heaton and I wanted to change how all elementary education majors in Nebraska were taught mathematics. And so we wanted a partnership with a mathematician and a mathematics educator that worked together. We wanted to link field experiences, pedagogy, and math instruction, and create math courses that are both accessible and useful for future elementary math teachers. So math teachers at Nebraska, future elementary school teachers take 4 courses. They're all courses focused on the math of the elementary curriculum, and they started in what we call the math semester, where they take a math course, math methods, another pedagogy course called the Learner-Centered Classroom, and they're out in schools 2 days a week in a field experience, all at one time, all focused on mathematics in a cohort. So the same set of 25 to 28 students are taking all 4 courses with each other, and so they form bonds of friendships, they work together, they study together, they come away believing mathematics is more important. And that was what this is. So here's a typical kind of problem we give them. You go to McDonald's, you can buy chicken nuggets, you can buy a box of 20, a box of 9, a box of 6. So if you want to get 32 chicken nuggets, you get a box of 20 and 2 boxes of 6. Well, but if you want to order exactly 31, you couldn't. If you think about it well, you convince yourself you couldn't order exactly 31. What is the largest number that you cannot order? And so you need to find an answer there. You need to explain why you can't order that number. So the number is 43. You need to explain why can't you get an order of exactly 43 with 6, 9, and 20. And then why for any number, including, let's say, 77 and 2,556,000, why any number larger you could order exactly. And then, so our students spend a lot of time learning to explain mathematics, but the problems need to be accessible. You could just sit there and think about 43 and try to do it and begin to get insight into why you can't do it. So we've been getting lots of grants. We started with that grant, then started with a middle school institute grant for $5.9 million, and then Nebraska Math Partnership, which was $9 million, and then Nebraska Noise, which was $3 million. So we've had lots of opportunity to offer opportunities for faculty to teach math courses, create math courses, and teach math courses for teachers. And then we tried to institutionalize this. We created a program called the Nebraska Math and Science Summer Institutes. We convinced the university that teachers were a special market, math and science teachers were a special market and should get a 20% discount. And we raised private funds to give teachers supplementary fellowships, because the idea is 25-year-old young woman with 1 child, husband, they're buying a house, they're starting a life, university tuition is expensive. And so they put off continuing education because they can't afford it. So we're doing everything we can to make it affordable. And we're also bringing the course to them. Now, I know nothing's big by Texas standards, but there are places in Nebraska that are 500 miles from Lincoln, Nebraska, right? So it's hard to get to the university, so we take courses where the teachers are. We taught courses in 12 communities last summer, and we taught so many courses between our grants and this program, we were 20% of all summer graduate enrollment at UNL. Okay, and 1,500 faculty, and the group I work with were 20% of all graduate enrollment. And then we also last year got $5.5 million from 2 foundations just to work with the Omaha Public Schools, funding massive professional development and continued research. And so the idea is there's an accumulation effect. Because the teachers that come out of our program are impressive to their employers, we are finally getting more funds to continue the program. So we've had 156 teachers earn a master's through our math and middle program, and another group in it right now. 221 have completed our primary math program, and about 61 more in it right now. Nebraska Algebra program for high school teachers, 75 teachers. New Teacher Network, 64 teachers, most of whom are still teaching. We had this Noyce grant, and then this Nebraska Math and Science Summer Institute so far has had 1,211 registrations, and this summer will be quite a bit more to add to this. And it's lots of people getting opportunities to work in the summer. We've hired 36 different UNL faculty, including 17 different faculty from the math department. We've hired 15 faculty from other colleges and universities. We've hired 87 graduate students to work in our programs in the summer, including 54 from mathematics. We've hired 33 undergraduates to be engaged either working in our office or doing research. And we've hired 76 master teachers to turn around and help be part of our instructional team. So we're trying to grow this community of people capable of providing professional development for other teachers. And we want teachers to develop strategies for solving problems, flexibility in thinking, an appreciation of the importance of precise mathematical definition and careful reasoning, ability to explain solutions, persistence, and self-efficacy. We've defined what we call by habits of mind, that's apprentice too small. And these are some of the names of courses we've created for teachers. We have a course for middle school teachers called Experimentation, Conjecture, and Reasoning. It's sort of the cycle of doing math. You get a question, and so you get your hands dirty doing an experiment. You check special cases. Then you come up with an idea. I think this is the answer. That's your conjecture. And then you set about to do the reasoning that solves the problem or answers the question, the cycle of doing math. Or a course we call Number Theory and Cryptology for middle level teachers. Or courses for high school teachers, Algebra for algebra teachers, Geometry for geometry teachers. So we've actually created 19 courses for teachers. Some for elementary, some for middle level, some for high school teachers. And so here's a message one elementary teacher sent me. She was in my undergraduate program in the math semester, and then later in our primarily math program, and then later we hired her to help her be a teacher. She was one of these 80-something teachers we hired. Did you know when I first came to the math block, I'd never heard of a base 10 system. I didn't know that it was our number system. I didn't know how it worked. I'd never heard anyone talk about place value. Had never been given a story problem without first being told which operation to use. Had never been asked to talk about or write about math. Had been told to show my work but never to justify an answer. Was terrible at mental math because I tried to do these algorithms in the sky in my head. It's hard to keep track of which numbers I borrowed from and which numbers I carried the one for without paper. I was never presented with the fact that fractions can go on a number line just like the whole numbers. My list could go on, but now none of these things are true. Now I feel very capable of doing mathematics. Even if I don't know how to do a particular problem, I know I have strategies to get started and persevere. In addition to that, I feel like I know how to help others feel capable of doing math successfully. So this is sort of the mindset that we want to reach with the teachers that we work with. And so the question might be, does it make a difference? So here is a graph of the Learning Math for Teacher, Knowledge of Math for Teaching assessment, and the black curve is a normal distribution of all elementary teachers in America. All right, and they've given this to thousands of teachers. If you worked with K-3 teachers, you might expect them to start the program slightly weaker in mathematics than K-6 teachers, because you might think there's a kind of natural selection that the school district or the principal puts the best math teachers in 5th and 6th grade. And that was true. Our teachers scored a little bit lower. But after our program, significantly higher, if y'all have taken a statistics course, it's 3/4 of a stay 9 shift. And that's very significant professional development. A different way of thinking about this is we hired some control teachers. We pay them a fee just to take this test every year. And while they're improving ever so slightly because of district efforts, the teachers in our program start off below the midpoint, but slightly better than this, because after all, they're volunteering to be in a program about mathematics. They have a positive attitude toward it. But they have significant gain during the program, and it continues to improve after they're well out of the program, and makes them dramatically better than the other teachers in the school district. So a lot of data that we are changing the knowledge of mathematics of teachers in our program. And then here's another kind of image. We do a thing called social network survey, and we ask teachers a lot of questions, including who do you go to talk about mathematics or for math advice? And so an arrow here says that this person goes to this person. Now, here, an arrow that would go back and forth in both directions, each goes to the other person for advice about mathematics. And this is an image of an elementary school, and the one thing that stands out is it's sort of sparse. I mean, there's not a lot of connections. Then a teacher's in our program and gets hired as a math coach, a K-3 math coach. Virtually everybody goes to that teacher, except maybe the 4th and 5th grade teachers. And it just, the whole conversation changes, and there's a lot more connection. People in the elementary school talking about mathematics than there used to be. So we're seeing this across all of the schools that we're participating in. And then we wanted to know, are the kids learning, right? So there's something called the Test of Early Math Achievement, and it's in its 3rd edition. And it is something that you give, it's an oral test that a trained person gives to like a 1st grade child. And asking them questions, showing them pictures, and asking them to answer math questions verbally. All right. It's a so-called age-graded test. So if Johnny is America's middle student, as Johnny and is getting the normal education, Johnny will always score 100, because as he goes from even preschool to kindergarten to 1st and 2nd, it'll just stay at 100. And so that's this middle point right here. So we took a look at the kids we've tested who've been, had teachers in our program. Some students in the fall, like in September, score above this middle level. Some score in this middle level, and some score below this middle level. All right? And after a year, every one of the groups improved. The kids who are already doing pretty good improved some. The kids in the middle improve a lot. The kids who are below normal get up into the normal level. All right? And so this kind of offers a hope that if you can give the children a number of good teachers a couple of years in a row, then you can, in some sense, overcome what I'll call parental advantage, because there's an awful lot of evidence that the knowledge gap of kids on day 1 of kindergarten is still visible in high school. All right, how much their orientation to reading on day 1 of kindergarten predicts how good they'll do in high school. Math, surprisingly, has a crossover effect. It predicts math achievement. It also predicts reading achievement. So if the kindergarten, 1st and 2nd grade we could change the paradigm, the teachers be much better prepared to teach mathematics, and if they can rapidly shrink the gap between those who come to school advantaged and those who are behind, and maybe in the long term we're going to have a much more equitable society in terms of what the educational system provides to them. So we're really pleased by the fact that we're having this kind of success with these students. And this is a different version. Our comparison teachers, their kids actually started off doing better, but over time, a statistically significant gap has opened up between the control group and the teachers in our program. And so, as a result, the local school district this year decided they would spend $528,000 this summer, giving it to us to provide more professional development for their teachers. Something that was quite a kind of sea change in how districts work. And then here's something that I call my Margaret Mead experiment. Nebraska historically didn't have state tests. It's only had a state test in mathematics for 3 years. It has its own test. And the state does not report data connected to the teacher or even to the building. But out in Gordon-Rushville, Nebraska, we're sort of in the upper part of Nebraska near South Dakota, western Nebraska, where there are more cows than people, that school out there is never going to have great teachers because they pay a big enough salary to recruit the best graduate from the University of Nebraska-Lincoln. The people there are there who want to live in that country and be like living in West Texas. People there who want to be there. They married a farmer or something like that. They happen to be a teacher, but they're bright. And so they got into our middle level program, math in the middle, and got their master's. And then Gordon and Rushville, the schools shrank, and so they had to consolidate. So there's one person who teaches everybody in 7th and 8th grade. And two people who teach in high school, but one of them teaches most of the 9th and 10th and some of the 11th grade kids. So here in comparison to the state, the district has 25% Native Americans who do 4% proficient in our state, all right? And 52% free and reduced lunch. So it's challenged in many ways. In the 4th grade or 5th grade, typical elementary school, these kids are about 20% behind state performance. All right? A little improvement in the 6th grade, but by the 7th grade, when our teacher takes over, they're ahead of the state score. In the 8th grade, they're dramatically ahead. And in the 11th grade, they're more than 20 points ahead, while the typical kid in the state performance trails off. They go up. There is simply no substitute for having a really outstanding teacher several years in a row. And so these teachers are able to start with a deficit and make dramatic improvement because they themselves are well-prepared middle school math teachers. All right? And so
This is the same year's data is not coming for.
right. I mean, this is, I think, the 2013 data. We started to notice it in 2012. Essentially what I did is I went on the state's website, they report by district, in places that seem to be small, and we seem to have a couple of teachers. I was looking for something. I spotted this. I made our people dig out as much data as we could. I made one of our researchers give me data on like 12 to 14 rural districts of very similar size to see whether this was a rural phenomenon. All right? And we lined up those 12 or 13 rural schools by free and reduced lunch percentage. All right? And so this school district was like the second worst in terms of having poor kids of all the rural districts. And dramatically better than any of the others in terms of state performance. I mean, there's few explanations left other than it's these two teachers that went through our program. And so they're my hero. And so that's what I wanted to say. What I think about it's important to our universities, it's important to our math departments. If you want to improve schools, focus on teachers. Teachers need professional development. The recommendations of our MET publication, and then sort of what we're doing in Nebraska.